Hi, welcome back to our third video for 1.2 functions and function notation. This is our last video for this lesson. We are looking at example 4 from the textbook. It says solve a problem using function notation. All right, this is what we are given. We're told the temperature of the water at the surface of a deep lake is 22 degrees Celsius on a warm summer's day. As Ronaldo scuba dives to the depths of the lake, he finds that the temperature decreases by 1.5 degrees Celsius for every 8 meter he descends. Okay, so we are asked in part A to model the water temperature at any depth using function notation. So we want to come up with a function that's going to give us the temperature versus depth. Okay, so it'd be like an equation. You could give me the depth and I could plug that in and then calculate the temperature of the water. All right, so here is our solution to part A. All right, so we will need to kind of set up some variables to get this equation. So I'm just going to say let D represent the depth. It's kind of a nice symbol for depth. Okay, and that's going to be measured in meters. Okay, we'll say below the surface of the lake. Okay, so let's say this was the lake here. D measures downwards from the top of the surface of the lake. All right, and we could also say, let's do, I'm going to do a comma here, and I'm going to say, and T represent the temperature in degrees Celsius. We'll say at this depth. Okay, so you give me a value for D, and I will tell you what the temperature is. So in function notation, we can say that temperature actually depends on depth. Okay, that makes a lot of sense. You give me the depth, I tell you the temperature. Okay, now for the equation. So we're told that the temperature goes down 1.5 degrees Celsius for every 8 meters. Okay, and the temperature at the top is 22 degrees. So every 8 meters that he goes down, the temperature drops 1.5 degrees, starting from 22. So we could probably start by writing 22 in here, and then the temperature is going to go down 1.5 degrees, okay, for every 8 meters. Okay. So what we could say here is we could put in D over 8. Okay. That way, when the depth is 8 meters, this will work out to 1 because we'll have 8 over 8, and the temperature will go down 1.5 degrees. Okay, let's look at part B. Use this function to determine the water temperature at a depth of 40 meters. So this question is asking me for the temperature for a depth of 40. Okay, so we want T of 40. Okay, well, good thing we know how to do this. This just means we substitute 40 into the equation. So T of 40 is going to equal to 22 minus 1.5. And then I'll just change colors to show the substitution. Okay, 40 divided by 8 works out to a nice 5. And then 5 times 1.5 is going to be 7.5. Okay, 22 minus 7.5 is 14.5 degrees. So we could say the temperature at a depth of 40 meters is 14.5 degrees Celsius. Okay, I'm just going to put my therefore symbol in front. Okay, and our last question. At the bottom of the lake, the temperature is 5.5 degrees Celsius. How deep is the lake? Okay, so they want to know how far would we have to go down so that the temperature is just 5.5 degrees Celsius. So this time they're giving us T and they want D. So we're going to substitute T of D equal to 5.5 and solve for D. Okay, so 5.5 is T of D, the left side of the equation. And now we can let that equal the right side, 22 minus 1.5 D over 8. Now we can go ahead and try to calculate D. So to calculate D, I got to isolate for it. I got to get it all by itself. Okay, so remember when you're rearranging equations, whatever you do to one side, you have to do to the other side. Okay, so I should probably get rid of this term first. So we're going to subtract 22 on both sides. Okay, that will cancel out this. Okay, 5.5 minus 22 is going to be equal to negative 16.5. And then we're going to have minus 1.5 times D over 8. Okay. All right, now this looks a little bit better. So we still got to isolate for D. So right now D is being divided by 8. And it's also being multiplied by a negative 1.5. So we want to reverse those to get D by itself. So I can reverse D divided by 8 by multiplying by 8. And whatever you do to one side, you got to do to the other. Okay. So that will help us cancel out that there. Okay, I'm just going to bring up Desmos just to do 16.5 times 8. This is going to be a negative value, negative 132. Okay, and our last step is to divide both sides by 1.5, negative 1.5. Okay, whatever you do to one side, you always do to the other. Okay, this works out to, I believe, take my previous answer, divide it by the 1.5, I get 88. Okay, the depth is measured in meters, so that'll be 88-meter dive. Okay, so therefore the depth of the lake (88 meters). Okay, and that is our application question, showing us how to work with function notation.